maybe you start? Or
No, you can start.
Welcome, and thank you very much for attending this session. I'm Shastri Kandukuri from DNV, and together with Matthias from Berenschot, who is working with us on a joint industry project for last 7-8 years. Today we are going to talk about standardization efforts in sustainability for oil and gas and maritime industries. So this work is part of our joint industry project together with 20 plus company consortiums that are working with us for last several years. And we have several goals into these joint industry projects, but one of it is about sustainability. We have seen certain gaps. That is what we are going to talk. So we wanted to support the global oil and gas and maritime industries' ambition to utilize additive manufacturing as an alternative supply chain, but how this can support the carbon neutrality of energy and oil and gas industries, this was a question. As you see, 3D printing has a potential to support, but today there is a lack of standardization, a method for quantifying and reporting sustainability aspect of additively manufactured parts. So yesterday I was attending one level below about a forum. They were discussing about the standardization effort, and we see that there is a gap, that there are no current standards that are guiding. So what we will come back to the details, but to show you with whom we are working in each phase of our JIP. Now currently we are in the phase 3 of the JIP. Every time we have 20 plus companies that are working, and this JIP is hosted by DNV and together with Berenschot. You can also see Uno, who is also coordinating there. So our joint industry project is aiming to develop our standard. We have developed a standard called STB203, and we are taking several fronts to help the standard to cater the end users' needs while addressing the manufacturer's requirements. So what we see that how did we develop this standard, or we are developing this standard, is by selecting several case studies and validating them over 2 years period in each phase, and take the best practices, also collect the best practice from the industry, and putting together a guideline that is again sent for verification by a number of partners, and then we release it. Okay, so as you see that DNV STB203 is a standard that we have released, and now in phase 3 we are establishing a guideline for sustainability reporting, and of course there will be a lot of questions and we will be happy to answer, and we will straight away show you again who is working in this JIP now. As you can see here, we have companies like Equinor, that is the end users, and we have companies like Fenice that are making the powder. So end-to-end companies with a lot of machine makers, also the OEMs. So it is a perfect mix of companies that can represent the interests of all the supply chain. So yes, so I will hand over to Matthias. Yes.
So in the JIP we have different goals and work packages. We work on design for AM. We focus on repair and remanufacturing. Look into quantification of sustainability, post-processing programs, part families, and we all do this in different part production case studies, as Sastri just mentioned. So today I would like to talk to you about one of the topics, which is quantification of sustainability. And I would like to do this through one of our case studies, which is a comparison of the footprint of a conventionally produced part and a 3D printed part. And the part is a water jet impeller, which you can see over here. So this part, the water jet impeller, is used to propel a ship by accelerating the water in the water jet system. So here you can see the system, and this is the actual part. So it's about 1,200 kilograms, 160 cubical diameters, and it's made out of stainless steel. And in order to be able to assess the sustainability, we wanted to let the assessment correspond to the actual life cycle of the part. So we identified different phases in the life cycle, which are redesign, material selection, part production, transport, use, and eventually end of life. And we think in all different phases there are advantages for AM when it comes to sustainability. However, today I would like to focus on a couple, which is material selection, part production, and transport. So our goal was to perform an LCA approach to conduct an environmental performance analysis on the production of the water jet impeller, in which we had two different cases, namely the 3D printed case and the conventionally produced case. And we thought we would be able to reduce the actual CO2 emission or the footprint of the part because we are able to reduce material waste, we could localize production, and reduce energy consumption. So the two cases, to quickly sum it up, we had the 3D printing case in which we 3D printed in Belgium and then we drove it by truck to Finland. And there was the conventional case in which we sandcasted in India, then we shipped it to Finland, and the last miles were done by truck in the shipyard. So we wanted to compare those cases on the three different phases I just explained to you. And we were doing this by using a sustainability calculator. And with the sustainability calculator, we could quantify the CO2 emission on material production, part production, consumables, and transport. And because we have an expert group in the JIP from the whole industry, we were able to verify certain input parameters which were under the calculations, and we could really see through the assumptions that were in the calculator. And what we found was a 77% reduction in CO2 emission. So on your left, you see the total CO2 emission, and on the right, you see the CO2 emission in kilograms per kilogram part on the different measurement points. So as I said, we measured on transport, part production, consumables, and material production. And by 3D printing, we were mainly able to reduce the CO2 emission of the part production and the material production.
So as you have seen this case study, that brings us the data, and that also gave us the opportunity to validate a lot of assumptions we made in the beginning. And so now I would like to show you that how we are developing a guideline based on this kind of a case studies. So again, now we are not here showing you how the complete methodology or the calculators. So we have used a third-party calculator and as a benchmark, and we have also consulted other currently available calculators. But once we made the guideline, we can actually go back and use our methodology to validate these guidelines or these calculating tools, so that the reporting will be same no matter whoever is following our guideline. So this is how we are bringing the standardization, and our approach will be aligned with the cradle to grave life cycle approach. And also we will provide the guidance in the guideline that will be given next year, we will be releasing by summer next year. So there will be a detailed guideline how to calculate the footprint of the parts, making comparisons and verifications, so that it will make it easier for the reporting, and users can trust it, and manufacturers can actually accurately report more or less in different, wherever they are geographically. So before concluding, we would like to say that yes, based upon the current results that we have conducted research for over 2 years, we can conclude that this 3D printing has a great potential, as many others also proven, for sustainable production method. And using that experience, we are able to standardize the quantification of carbon footprint of AM parts by creating a framework for reporting. And so we are separating it from the calculators. And of course, also manufacturers have flexibility to choose and propose some of it. So they have opportunity for customization. And of course, we are aligning to a lifetime analysis approach, and also the methodology of manufacturers, for manufacturers to use and customize as a best practice will be a very good point to take this forward, so that we don't close the doors for the more innovation, and users can have confidence in the reported footprint, so that they are also legally reporting to authorities. So this will provide a better basis. Thank you so much. Appreciate. Yeah.